Hello, I'm Jacob.
And I'm David.
And welcome to Physics of...
Physics of what?
Nothing, David. It's just the name of the project.
So, welcome to Physics of Nothing.
No, David, it's Physics of... We're doing it on tennis. It's just the name of the project. It's Physics of Tennis.
Okay, so, welcome to the Physics of Tennis.
Yes, David. Today on Physics of, we'll be working on the different spins on a tennis ball and how it flies through the air. First, we'll be showing the top spins on a tennis ball.
Very interesting. Did you know air had a lot to do with the spin of a tennis ball?
Yeah, the air above it goes like forward, so it flies with the ball. Then the air below it goes under it, so that kind of gets a spin going.
Very good, Jacob. And let's pop it away at a few clips. Next, we'll show you some examples of side spin.
What causes side spin, David?
Well, for a tennis ball, side spin is caused when the racket hits a ball at a certain angle, such as this.
That sounds very interesting. So, where can I see some examples of this so-called side spin?
Right here.
Okay, then let's send it out to Jimmy with the side spin. That right there took some effort.
Not really, it's just physics. And a little practice.
Well, how about we get on to our next clips?
What's in these next clips?
Well, our next clips, they entail backspin.
Backspin. How is backspin created with the tennis ball?
Well, backspin is very complicated. You have to hit the ball at just a certain angle. So when the ball hits the ground, it spins backwards and flies back to you. So they have no chance.
Well, that's interesting.
Yeah, it also sounds like it takes some skill. But that's why I'm sending it over to the expert. Wow, did you see that backspin?
Yeah, I did, man. That was a great shot.
Dude, that was expert. Like, would you like to see that in more detail and up close?
Oh, yeah, I would.
Oh, good, good. Then let's send it over to Jared with slow motion. Wow, did you see that backspin?
Yeah, I did, man. That was a great shot.
Dude, that was expert. Like, would you like to see that in more detail and up close?
Oh, yeah, I would.
Oh, good, good. Then let's send it over to Jared with slow motion. Well, now let's take a moment to see the rest of these brilliant spins in slow motion.
Sounds like a great idea. Let's send it over to Jared.
Well, today was a lot of fun, don't you think, David?
Yeah, I had a good time today. What was your favorite part about learning to spin?
Well, my favorite part was learning about Jimmy's backspin.
You like Jim's backspin? I'd say that was a pretty cool shot. My favorite part was the towel whip.
Oh, dude, that was interesting. I don't know what that really has to do with tennis, though, but definitely has something to do with physics.
It does. And Newton's first law of physics says that an object in motion stays in motion unless another object of equal or greater force acts upon it. So in the the towel whip, the starting force was Jared's arm, and the force acting against it was also Jared's arm pulling it back.
That's actually a very good analysis. Pretty clever.
Yeah, it is.
Well, since modesty is actually a clear value here, thank you very much for joining us today in this episode of Physics of. Well, today was a lot of fun, don't you think, David? Well, today was a lot of fun, don't you think, David?
Yeah, I do. What was your favorite part about today?
Well, my favorite part was Jimmy's backspin.
That was a pretty cool shot. But, my favorite part was actually tower whip.
Yeah, that was pretty interesting. It was pretty cool.